Next fundamental quantity is the temperature. We know the temperature is the degree of hotness or coldness of an object. It's not meaning heat. It's a degree of what? Hotness or coldness of an object. And different scales are there. We know degree Celsius, degree Fahrenheit, Kelvin are the common scales in order to represent what? Temperature. In Celsius scale, the scale is calibrated from 0 degrees Celsius to 100 degrees Celsius. And in the case of degree Fahrenheit scale, the temperature is in the range between 32 degrees Fahrenheit and 212 degree Fahrenheit. And the unit conversion, the degree Fahrenheit is equal to 9 by 5 degrees Celsius plus 32. If we want to convert 50 degrees Celsius into Fahrenheit, what we do? Yes, we can use this equation. F is equal to 9 by 5 degrees Celsius plus 32. And here is equal to 9 by 5 into degrees Celsius. What the value degrees Celsius? Yes, 50 plus 32. 550. Here 10. We get 90 plus 32. What's the answer? Yes, 122. Okay, that is 50 degrees Celsius means it is 122 degree Fahrenheit. Is it clear? Yes. Then Kelvin, we already studied the Kelvin and what? Degrees Celsius. In order to convert a degree Celsius scale to Kelvin scale, what we do? Yes, we add 273.15. And one important thing is that the degree Celsius scale shows negative temperature. We familiar with minus 32 degrees Celsius, minus 20 degrees Celsius, like that. And degree Celsius scale shows negative temperature, but Kelvin scale never shows negative temperature. It only shows positive temperature or the positive values. Okay, once more, temperature means the degree of hotness or coldness of an object, and different scales are used. And in the Celsius scale, what's the value? Yes, 0 degrees Celsius to 100 degrees Celsius, and Fahrenheit scale, it's from 32 to 212 degree Fahrenheit, and the conversion, degree Fahrenheit is converted into Celsius scale by using the equation 9 by 5 degrees Celsius plus 32. Then Kelvin converted into what? Yes, the Kelvin conversion or the degree Celsius conversion, Kelvin is equal to degree Celsius plus 273.15. If we convert the Celsius or the Kelvin temperature to Celsius scale, what we do? Yes, subtract 273.15. Okay, add 273.15 in order to convert degree Celsius to Kelvin. In order to convert Kelvin to degree Celsius, we subtract 273.15. There are some terms related to these physical quantity or the physical experiments. And two important terms is precision and accuracy. What is precision? Yes, closeness of various measurement, that is precision. For example, during an experiment, a student get the values 9.3, 9.5, 9.2, 9.4. If a student is doing an experiment or if a student is calculating the length of a particular object, one time he got the value 9.3 meter. Next time he got the value 9.5 meter, and again he got 9.2 meter, and again he got 9.4 meter. We can say that these values are very close to each other. Some point difference are there. So these values are precise value. These values may or may not be correct, but this is precise value. That means closeness of various measurement. If a person doing a particular experiment more than 2 or 3 times and he got all the values what very close to each other, then we can say he precisely doing his experiment. Okay, now the concept is clear. Yes, and precision means what? Closeness of various measurement, that is called what? Precision. And what is accuracy? Suppose the correct value of this measurement, the correct value of the length of that particular object is 9.6. Suppose it's 9.6 and one student got the value 9.5 and another student got the value 10. Okay, if a student do the same experiment and the actual length of that particular object is 9.6 and one student got the value 9.5 and another got the value 10. Now, which value is very close to this correct value? Yes, the 9.5. So, we can say this value is somewhat accurate. That means the agreement of particular value with the true value. How close that particular value with the true value. Here the true value means this 9.6. That's the actual length of that particular object. And a student got the value 9.5. It's somewhat same or somewhat near to this 9.6. So this value is what? Accurate. Is it clear? Yes. Accuracy means agreement of particular value with true value. But precision means what? Closeness of various measurement. If a person doing the same experiment several times and he got the close value, we can say he is very precise. And a person doing the same experiment and he got the value which is equal or what near to the true value, we can say he doing the experiment accurately. And next important term is the significant figure. That's an important topic in this chapter. Significant figures. Significant figures means we know while doing experiment we get the values like this 28.636265 like this. Large decimal values. We got what lot of values after the decimal point. And we don't know which are the values that we want to consider. Or after the point, how many values we consider and how many values are certain values or the correct values, we don't know. In that instant, we use some set of rules and we can find the significant figures, the number of significant figures in that particular value. Here, look at this. The significant figures means meaningful digits known with certainty, and that digit is already there, they are certain. For example, 15. 15 is a number. 1, 5, 2 digits combined we get 15. And 15 is a number and there is a certain number. So we can say it contains two significant figures. Like that, there are some set of rules in order to find the number of significant figures in a particular number. What is significant figure? Yes, significant figure means meaningful digit known with certainty. Meaningful digit known with certainty. I think all of you clear about these three small topics. The first one, precision. Precision means the closeness of various measurement. Then accuracy means the agreement of a particular value with the true value. And significant figures, the meaningful digit known with certainty. That number of digits are certain in that experiment or certain in that particular number. Okay. Then how to find the number of significant figures? There are some rules in order to find the number of significant figures. The first one, look at the first one. All non-zero digits are significant. If a number contains no zero, then all the numbers are significant. For example, 111 or 222. How many significant figures are there? Yes, 1, 2, 3. 3 significant figures are there. All non-zero digits are what? Significant. But in this case, 202. How many significant figure is there? Yes, in this case we can say the non-zero digits are significant. So 2 significant. But another rule is there. The zeros between the non-zero digits are significant. So here 3 significant figures are there. We will discuss later. Another one, 200. How many significant figures are there? 200. Yes, only one significant figure is there. Because 2 is only the non-zero digit and 2 zeros are there. So the first one, all non-zero digits are significant. That's the first rule. All non-zero digits are significant. The number which do not contain what? A zero, all the numbers present in that are what? Or all the digits present in that number is significant. And next one, zeros preceding to first non-zero digits are not significant. For example, 0.05 is there. And here, this one is the non-zero digit. 5 is a non-zero digit. And zeros preceding the first non-zero digit. That means the zeros before a first non-zero digit is not significant. So here only one significant figure. Another example, 0.0008. How many significant figure is in this number? Yes, only one significant figure, because these preceding zeros before a non-zero digit is not significant. Another one, 0.0018. How many significant figure? Yes, two significant figure. We only consider 1 and 8 as significant because these three zeros are preceding the first non-zero digit 1. So those zeros are not significant. Is it clear? Yes, the first one, all non-zero digits are significant. Next one, zeros preceding to first non-zero digit. Zeros preceding to first non-zero digits are not significant. So the example. Then, zeros between two non-zero digit are significant. Zeros between two non-zero digit. For example, I already said 202. Here two non-zero digits are there, 2 non-zero digit and between those non-zero digits there is a 0. Here we consider this 0 as significant. Clear? That means zeros between two non-zero digits. So how many significant figure in this number? Yes, 3 significant figure. But here 200, how many significant figure? Only one significant figure, because these zeros are not considered. But here we consider this 0 because this 0 is in between two non-zero digit. Another example, 200 and 200.36. How many significant figure? Yes, here also we consider these zeros as significant because the zeros are in between the non-zero digits. So how many significant figure in this number? Yes, 1, 2, 3, 4, 5. 5 significant figures. Okay, the first rule, all non-zero digits are significant, and second one, zeros preceding the first non-zero digit. Preceding means zeros before the first non-zero digit are not significant. We cannot consider such digit or such zeros as significant. And next one, zeros between two non-zero digits are significant. Okay, 2005. How many significant figure present in 2005? Yes. 1, 2, 3, 4. We consider these two zeros as significant because these two zeros are between the two non-zero digit 2 and 5. Okay. And next one. Zeros after decimal points are significant. And in 100, how many significant figure are there in 100? Only one, because all non-zero digits are significant and all zeros are not significant. But zeros after the decimal point is taken into account as significant figures. For example, here 100.0. How many significant figure? Yes, we consider this 0. So 1, 2, 3, 4. 4 significant figure. Okay, that's a fourth rule. Zeros after decimal points are significant. Zeros after decimal point is considered as what? Significant. Then counting numbers or object. For example, 6 pen. That is certain number, 6 pen. 5 pencil. Then 20 eggs or 30 balls. In all these, the number is constant or the number is certain. In that number or in that instant, that contain what? Infinite number of significant figure. For example, 30 egg. How many significant figure? Infinite number of significant figures are there. Okay. These are the rules in order to find what? Significant figures. Once more, the first one, all non-zero digits are significant. We saw the example. Then next one, zeros preceding to first non-zero digit. Preceding means zeros before the first non-zero digit are not considered as significant. The next one, zeros between two non-zero digits are significant. And next one, zero after decimal points are significant. And last one, counting numbers of object contain infinite number of significant figures. Laws of chemical combinations. We know elements combine together to form compounds. And mainly there are 5 laws which govern the formation of compounds from constituent elements. Let's check which are the 5 laws. The first one, law of conservation of mass. Next one, law of definite proportion. Third one, law of multiple proportion. fourth one, Gay-Lussac's law of constant oleum, and fifth one, Avogadro's law. First you study the name of these law. Which are the 5 laws govern the formation of compounds? Yes, law of conservation of mass. Next one, law of definite proportion. Next one, law of multiple proportions. Then Gay-Lussac's law of definite or constant oleum, and fifth one, Avogadro's law. Let's see one by one. The first law, law of conservation of mass. And this law was put forward by Antoine Lavoisier. The name of scientist is very important. The law of conservation of mass put forward by Antoine Lavoisier. And the law states that mass can neither be created nor be destroyed. What's the law? Mass can neither be created nor be destroyed. For example, if you are preparing water and we take 10 liter hydrogen and 10 liter oxygen, and 10 and 10, they combine together, we get what? 20 liter of water. That means whatever the amount of the reactant that we take, we get that much amount of product. That is law of conservation of mass that put forward by the scientist Antoine Lavoisier. The mass can neither be created nor be destroyed. That's the law. And next one, law of definite proportion. The scientist Joseph Proust was the scientist put forward this law of definite proportion. And the law states that a given compound always contains exactly the same proportion of element by weight. For example, H2O. There are different sources of water is there. And what's the mass of hydrogen in water? Yes, hydrogen atomic mass 1 and 2 hydrogen atoms present. So 2 is the mass of hydrogen. Is 2. The mass of oxygen. What's the mass of oxygen? Yes, 16 is the mass number. So 16 is the mass of oxygen. Or we can simplify as 1 is to 8. That's the ratio between, the simplest ratio between hydrogen and oxygen in water. And in water, always, whatever be the source of water, or if the water we prepare in the laboratory, which contain 1 is to 8, what? Hydrogen and oxygen by simple ratio. This ratio of what? Weight. Always present in the simple ratio or the constant by the weight. Okay, that is law of definite proportion. What is law of definite proportion? Yes, given compound always contains exactly the same proportion of element by weight. And here in water, hydrogen and oxygen, the mass of hydrogen is 2 and oxygen is 16 and simple ratio 1 is to 8. Always that's fixed in the case of water. Another example, carbon dioxide. In the case of carbon dioxide, we know carbon. What's the mass of carbon? Yes, 12, the mass of carbon, and 2 oxygen atoms present. So 1 oxygen atom 16, 2 oxygen atom 32, and 12 is to 32 is the ratio between carbon and oxygen in carbon dioxide, and it's always fixed whether it is produced in the atmosphere or whether it is produced in the laboratory. Whatever it is, always in the ratio 12 is to 32. That's about law of definite proportion, which put forward by the scientist Joseph Proust. Once more, law of definite proportion law of definite proportion says that given compounds always contains exactly the same proportion of element by weight. Next law, law of multiple proportions, and this law was put forward by the scientist John Dalton. Okay, John Dalton was the scientist who put forward the law of multiple proportion. Let's check this law using a simple example. Look, here hydrogen combined with oxygen, we get water, H2O. We can write like this, H2 plus O2 gives what? H2O. And the same case, H2 plus O2 gives H2O2. Hydrogen and oxygen combine together to form one compound named as water. Here the equation is not balanced, so I put half here, half. And here H2 plus O2 combine H2O2. What is H2O2? Yes, hydrogen peroxide. What is the mass of hydrogen here in the first compound, the formation of water? What is the mass of hydrogen? Yes, 2. Hydrogen, 1, atomic mass of 1 hydrogen is 1. Here 2 hydrogen atoms are there, so 2. Then oxygen, half O2 means 1 oxygen is there and the mass is 16. Suppose here 2 gram, 16 gram. Then water, H2O. What's the mass? H2, 2 hydrogen atom. So mass number 2 plus oxygen 16. So total 18 gram. And here what about H2? Here also 2 gram. And oxygen, O2. Here O2 is what? 32. Then what is H2O2? Its mass is 34 gram. 34 gram because H2, atomic mass 2 plus oxygen, 2 oxygen atoms, 32. So 32 plus 2, 34 gram. Okay. So we can see that here hydrogen combines 2 gram combines 60 gram, we get 18. Here 2 gram combined 32, we get what? 34. And this also obey the law of what? Conservation of mass. 2 plus 16, 18. Here 2 plus 32, 18. Okay, that's one side. And here, what happened? In these two compounds, that H2O and H2O2, the one element combined in fixed ratio. That is the hydrogen. The mass is fixed in these two compounds. And another element, what happened to another element? In the case of these two compounds, the combination, the first one, oxygen in the ratio 16 and next one, oxygen in the ratio 32, or we can simplify as 1:2. We can say the one element is fixed, the mass of one combining element is fixed in order to form more than one compound, and another element form is combining by the fixed ratio by mass. Is it clear? Here hydrogen is constant and oxygen, what happened to oxygen? It combines by simple ratio, simple whole number ratio. Let's see the law. If two elements can combine to form more than one compound, here hydrogen and oxygen, two elements combine together to form two compounds, H2O and H2O2. What happened? The mass of one element that combines with a fixed mass of other element. Here fixed mass, hydrogen has fixed mass, and the next element, oxygen, combines with the hydrogen. Okay, and are in the ratio of simple or small whole number, and the other element combined with the fixed mass of one element in the simple whole number ratio. Is it clear? This law of multiple proportions.